Okay, we're now going to look at some questions where the question is going to ask us to find the equation of a tangent. So remember that a tangent's a straight line. So to find the equation of any straight line, we need the gradient and we need a point that lies on the line. We'll get the gradient through differentiation. So let's try a few of these. Find the equation of the tangent to the curve y equals x cubed, where x is equal to 2. So to find the equation of the tangent, we need point gradient. So let's first of all get the gradient. So we'll differentiate, that's 3x squared. We're looking for the gradient when x equals 2. So that's 3 lots of 2 squared. 2 squared is 4 times 3 is 12, so the gradient is equal to 12. We've got the x-coordinate. To find the y-coordinate, we would sub the x-coordinate back into the equation for y. So sub x equals 2 into y, that will be y equals 2 cubed, and y is equal to 8. We'll then get the point 2, 8, and we've got the gradient that we got through differentiation, which was 12, and put that into y minus b is equal to m bracket x minus a. Y minus 8 is equal to 12 bracket x minus 2. So that's y minus 8 equals 12x minus 24. Bring that over, and the final answer is y equals 12x minus 16. Okay, let's try another simple one. Find the equation of the tangent to the curve y equals x squared plus 3x at x equals 1. Okay, so to find the equation of the tangent, point and gradient. So let's first of all get the gradient by differentiating, and that's 2x plus 3. We're then looking at the gradient when x equals 1, so that's 2 lots of 1 plus 3, and the gradient is 5. So to get the y-coordinate, we're going to sub x equals 1 into the equation for y, because that will obviously generate a y-coordinate. So that's y equals 1 squared plus 3 lots of 1, and that's y equals 4. So if we get the point, which is 1, 4, and the gradient of 5, y minus b equals m bracket x minus a. Y minus 4 is equal to 5 bracket x minus 1. That's y minus 4 is equal to 5x minus 5. I'm going to bring that over, and that'll be y equals 5x minus 1. Okay, let's try another, which is going to be find the equation of the tangent to the curve y equals 2 over x when x equals minus 2. So let's first of all prepare to differentiate. That'll be 2x to the minus 1. Now differentiate, bring the power down, multiply, take 1 away from the power. That'll be minus 2x to the minus 2, which can now be written as minus 2 over x squared. And it's ready for subbing in. So x equals minus 2, that'll be minus 2 over minus 2 squared. That's minus 2 over 4, which is minus 1/2. We're going to sub x equals minus 2 into y to get the y-coordinate. So that'll be y equals 2 over minus 2, and that'll give me minus 1. So the point then is minus 2 minus 1, and the gradient is minus 1/2. Y minus b equals m bracket x minus a. That's y minus minus 1 equals 1/2 bracket x minus minus 2. So that's y plus 1 equals 1/2 bracket x plus 2. 2y plus 2 is equal to 1 bracket x plus 2. That's then 2y plus 2 equals x plus 2. Bring that over, and that will be 2y equals x. Next one, find the equation of the tangent to the curve 5 root x when x is equal to 16. So again, find the equation of the tangent. Tangent is a straight line, I need point and gradient. We'll get gradient by differentiating the function. I'm first of all going to prepare to differentiate. That's 5x to the half. Bring the power down, multiply, take 1 away from the power. 5 times a half is 5 halves. X to the minus 1/2. So remember, that's a half take away 1, half take away 2 over 2, which is minus 1/2. Okay, so let's now tidy this up so I can sub something in. Bring it back down, that'll be 5 over 2x to the positive 1/2, which can now be written as 5 over 2 lots of root x. Okay, so we're looking for the gradient of the tangent when x was equal to 16, so let's sub that in. And that will be 5 over 2 lots of root 16. 5 over 2 times 4, and that is 5/8. So the gradient is equal to 5/8. Now let's find the y coordinate. So we're going to sub x equals 16 into y. So that's y equals 5 lots of root 16. That's 5 times 4, which is 20. So I've got my point, which is 1620, and I've got the gradient, which is 5/8. Y minus b equals m bracket x minus a. Y minus 20 equals 5/8 bracket x minus 16. Let's multiply through by 8. That will be 8y minus 160 is equal to 5 bracket x minus 16. 8y minus 160 is equal to 5x minus 80. Let's bring that over, and that will be 8y equals 5x plus 80. Okay, let's try a question that's been broken into 2 parts. So, for this question, find the equation of the tangent to the curve y equals x cubed minus 2x squared plus 7 at the point where x equals 2. Okay, so let's differentiate. First of all, dy by dx equals 3x squared minus 4x, and we're looking at the gradient when x equals 2, so that's 3 lots of 2 squared minus 4 lots of 2. 2 squared is 4 times 3 is 12, minus 8 is equal to 4. Let's sub x equals 2 into y to get the y coordinate. So it'll be y equals 2 cubed minus 2 lots of 2 squared plus 7. 2 cubed is 8, minus 2 squared is 4 times 2 is 8, plus 7. And that will give me a y coordinate of 7. I've now got a point which is 2, 7, and the gradient is equal to 4. Y minus b is equal to m bracket x minus a. Y minus 7 is equal to 4 bracket x minus 2. Y minus 7 is equal to 4x minus 8, and that will be y equals 4x minus 1. Okay, we're then asked, part B, to find the point where the tangent cuts the curve again. So there is the tangent, y equals 4x minus 1, and the curve was y equals x cubed minus 2x squared plus 7. So that's insinuating then that we cut at least one more time. So to find that point of intersection, we would make y equal to y. That's x cubed minus 2x squared plus 7 is equal to 4x minus 1. Okay, so let's bring this across and make it equal to 0. X cubed minus 2x squared minus 4x plus 8 equals 0. Now we already know that there's a point of contact at x equals 2. So this is now verged into polynomial area. Okay, so I'm going to do synthetic division, and I should find the x equals 2 works. So 1 minus 2 minus 4 and 8, drop the 1 down. 1 times 2 is 2, 2 take away 2 is 0. 0 times 2 is 0, 0 minus 4 is minus 4, and minus 4 times 2 is minus 8. And that will now give me x squared minus 4. Difference 2 squares, x plus 2 bracket x minus 2 is equal to 0. And I'll get x equals minus 2 and x equals 2. I already have the result of x equals 2, so I can now concentrate on x equals minus 2. So to get the y coordinate, I now sub it back into an equation for y. So I can choose either. I've got 2, so I'm going to choose the one y equals x cubed minus 2x squared plus 7. So that will be minus 2 cubed minus 2 lots of minus 2 squared plus 7. That will give me minus 8. Minus 2 squared is 4 times 2 is minus 8 plus 7, which would be minus 9. So the second point of contact then will be minus 2 minus 9. Okay, let's try another one, but just a slightly different request in the question. This question says the gradient of a tangent to the curve y equals x to the 4 plus 1 is 32. Find the point of contact of the tangent. Okay, now if you think about it, this question has already given me the gradient of the tangent, therefore to differentiate is to find gradient, which would be 4x cubed, but I already know that result, which is 32, because the question's given me that. What the question's looking for is the point of contact. Okay, so we need an x and a y coordinate. So the gradient of tangent is 32. Remember that if you differentiate something, that's you finding the gradient of tangent. So when you differentiate and get 4x cubed, that then must be equal to 32, since the question says that that's the case. So x cubed is equal to 32 over 4, which is 8, and x equals the cube root of 8, which is equal to 2. So the x coordinate is 2. How will I find the y coordinate? Well, that's pretty simple. Just sub into an equation that starts with y. So sub x equals 2 into y. So that will give me y equals 2 to the power 4 plus 1. 2 to the power 4 is 16. 16 plus 1 is equal to 17. 17. Okay, let's try another one like that. Find the point of contact on the curve y equals x squared plus 3x plus 5, at which the gradient of the tangent equals 9. So remember, the gradient of the tangent is what I get when I differentiate. So that's 2x plus 3, and I'm told that that is equal to 9. So that would be 2x equals 6 and x equals 3. So my x coordinate is 3. How to get my y coordinate? Sub into an equation which starts with y. So sub x equals 3 into y. That will be y equals 3 squared plus 3 lots of 3 plus 5. That's 9 plus 9 plus 5, which will give me 23. The point is 323. Okay, let's try one final question. Find the points of contact, so more than one, on the curve y equals x cubed minus 4x for tangents with gradient equals 8. Okay, so the first move is to differentiate. 3x squared minus 4, well, that is the gradient of the tangent, and that is equal to 8. I then get 3x squared is equal to 12, x squared is equal to 4. If I take the square root of 4, I'll get a positive and negative result, both plus and minus 2. So to find first point of contact, I'm going to sub x equals 2 into y. That'll give me y equals 2 cubed minus 4 lots of 2. That's 8, take away 8, which is 0. So the first point of contact then, which I'll call POC 1, point of contact 1, is 2, 0. I'll find the second one by subbing in x equals minus 2 into y. And that will be y equals minus 2 cubed minus 4 lots of minus 2. That's minus 8 plus 8, which is 0. So the second point of contact then is minus 2, 0.